Hello, this is Dr. Ali Al-Bahrawi, and our session now is a bit longer than the sessions before. It's about graphics and computers. We will start by an introduction, then defining some graphics terms, then why and when we use graphics, and the relation between graphics and spreadsheets, and we get into a detailed discussion of the common types of graphics and how we use them. Then we give plenty of examples after defining each type of graph. The graphical representation is far more effective in conveying the sense of the data than tables with numbers. And this statement is a general statement, but it may have some exceptions. If a picture is worth 1,000 words, as the Chinese proverb says, a table with numbers can tell us an interesting and sometimes a tragic story. Why we use graphics? We use graphics because they bring facts to life, they simplify ideas, they convince audience, they reinforce ideas, they create interest, and they are compact and universal. Graphics terms. Any non-textual portion of document is called graphics. Therefore, illustrations, visual aids in oral presentations, tables of numbers and words, figures of different kinds, charts, drawings, maps, photos, they are all called graphics. But what we are going to talk about in this session is the graphs, especially those in Microsoft Excel, like bar charts, pie charts, line charts, etc. But this is different from the technical drawing for the Faculty of Engineering students who are going to study in a separate course. When we are writing a document, we have to refer graphics in text. And the graph is mentioned either by number, by title, by page number, or by reference. And it has to be on the same page, and if not, on the following page or on the opposite page. And sometimes in appendices, but I prefer to have the graph close to the describing text. And it has to be positioned vertically if you are reading documents, or a fold out, and if not, and we have to present it horizontally, it has to be looked at when you move the document clockwise. A general rule is to avoid clutter. A graph should not be busy and crowded. To make the graph readable, we have to include titles, notes, keys, and data source. In the following examples, I'm not going to abide by this last condition here, because the purpose of the slides is to show the relation between data and the type of graph, not a complete graph in a document. There is strong relation between graphics and spreadsheets. Why? Because spreadsheets are easy to learn and use, and this is very important to me, calculation and graphs are in the same place. This is very good for engineers. Why? Because they can create simple simulation models, and they can have graphics, and they use a what-if analysis by changing the inputs and looking at what happened to the output in a graphical form, and this was very difficult to do before the invention of spreadsheets. There is plenty of options, and this is good and bad at the same time. Therefore, you have to think, then do. Why? Because it is very quick. If you are not careful enough, you can create mistakes. These are the common types of graphics. There are column graph, bar graph, line graph, scatter graph, pie chart, donut chart, radar chart, stock diagram, area chart, 3D chart, contour maps, custom graphs, and pictographs. We are going to go through every one of these one by one. But in order to choose the right graph, maybe this is the most important slide in the presentation. You have to ask yourselves about the nature of data. Is it whole and each parts? Or is it simple comparisons? Or multiple comparisons? Or trends with time or distance? Is it frequencies of occurrences? Or it's a relation between variables? If you can decide what kind of data you have, you can easily choose the best graphical representation. Computers, and spreadsheets in particular, provide alternatives and speed. And this causes some difficulty in choosing this type of graph. Why? Because there are too many alternatives, and this graph is generated very quickly. Therefore, it doesn't give you enough time to judge if this is a good graph or not. My advice to you is to just think before doing, and in another presentation I will give you another advice by looking again at what you have done. If you look at the anatomy of graph, there are in the spreadsheets types and subtypes, and these subtypes are custom types. There are categories and series which represents X and Y coordinates, and we have titles, axes, grid lines, legend, data labels, data table. They are all available, but you don't need to use everything. Why? Because we don't like to make our graphics cluttered. Therefore, you have to use with care. This is the types and subtypes. A simple table I created about arrivals of tourism in millions in 2004 it's a simple comparison showing the country and the number. And if you go to the column, which is the chart type, you will find 5 subtypes: clustered columns, stacked columns, 3D columns, and as you can see here, the options I mentioned. If you go, this is an old version of Excel, but they are available in all versions. You find here different chart options. We have titles, we have axes, we have grid lines, we have legend, we have data labels, and we have data table. Each one of them gives us a piece of detail. Do you need it or not? Depending on the message you are sending. We are now going to go the examples of chart types one by one. This is the per capita share of water in different regions of the world: in South America, in North America, in Africa, in Europe, and in Asia. The numbers are in cubic meters per person. Again, the details of tables, the details of graph is not what we are looking for. We are looking for the type of graph and a description of this type. Because it is simple comparison, we have to use, or one of the options is to use a column chart. Here I like to draw your attention to something, that the x-axis here appears as labels, and it is positions between the tick marks, and the data here may not appear in this order because I sorted the data. This is one important advice. When you are plotting data, you ask yourself, would I keep the numbers as they appear in the table, or there might be some advantage of sorting the data. In this case, I sort the data to be able to rank the per capita share. I found that in South America they are number one, and in Asia they are the last one, and North America comes second. What is a column chart? It shows variation over a period of time or illustrates comparison among items. The categories are organized horizontally, which are the names of the regions of the world, and the values are organized vertically. Therefore, categories in x-axis and values are put on the vertical axis. You can use one of the subtypes is 3D perspective that compares data points along two axes, but it has a 3D perspective like you're going to see now. The most two important parts or subtypes of column graph is stacked and clustered, and this is an example that needs a lot of deep thinking. We like to present this table of a company that shows sales and profits with years. These years you have to look carefully. If the difference between years is the same, it goes 1993, 94, 95, 96. If the distance between years are the same, I am allowed to use a column graph for comparison. If they are not the same, column graph may not be a good idea. As you can see now, we have two graphs, one to the left, one to the right. The left graph is a stacked column. The right is clustered column. And the question here, which of these two subtypes of column graph presents the data correctly? It is the right one. Why? Because I cannot add sales to profit. When you are using stacked column, this has to be the same units. I cannot add oranges and apples. And also this gives you to the graph to the left a wrong idea about the performance of the company. Somebody can have a conclusion that this company is doing well because the column height is increasing with time. But the real story is here, where even though the sales are increasing, but the profits are decreasing with time. And this is a good advice to show you that graphical presentation can be used to deceive people and give them the wrong impression. Another idea is to ask yourselves, where are the series and where are the categories? This is a simple example of some irrigation mesa, and each mesa irrigates wheat, berseem, and beans in fiddans, and I like to present this data graphically. I have two options, as in the previous example, one to the left and one to the right. And in both cases it is stacked column, but every graph sends a different message. The graph to the left shows the areas planted of wheat, berseem, and bean for every mesca, but the graph to the right shows how the three different types of crops, how they are distributed among mescas. Both of them are right, but you have to ask yourself, what is the message you want to send? Is it the message to the left or the message to the right? In Excel, there are options to switch between the two options by clicking a button. 3D versus 3D effect. This is another example showing the years, the expected lifetime of people in the developing and developed countries. And we have three different points in time: 1950, the present time, and the year 2050. We have two options again, as I did before. One of them is life expectancy in 3D effect, and the graph to the right is a three-dimensional graph. The difference between the two is the graph to the left has two dimensions only, x and y, or categories and values. Here we have three axes. One of them for the x-axis, which is the time, and the y-axis is either developing or developed, and the z-axis is the years defining life expectancy. This is again left to you. I myself personally don't like 3D effect, but it's up to you, because most of the rules I mentioned to you in this presentation, 75% is guidelines and 25% is left to your personal preference. Therefore, it is up to you to show your personality when you choose the type of graph to represent data. We have only 25% to show your preferences. This is another type of data, another type of graph showing the languages and the people in millions speaking these languages, starting with Chinese, the Mandarin, English, Spanish, Bengali, Hindi, Portuguese, Russian, Japanese, German, and Chinese, and it's simple comparison. Therefore, somebody may say we can use the same graph as before. No, I actually, because of something that I'm going to explain to you, choose a different type of graph. I chose a bar chart. Why? To show the data. This again, I did not use the data in the original table. I sorted it so that I can see the rank of each item, and I chose a bar chart because of the length of the categories. If I choose x-axis, I will not be able to write all this on a horizontal axis. Therefore, I preferred to convert or to rotate the graph 90 degrees and use a bar chart, which is very similar to the column chart, only it's rotated 90 degrees. This is a bar chart. It shows individual figures at a specific time or illustrates comparisons among items. The categories are organized vertically and values horizontally, and this is the effect of rotating the graph 90 degrees. Stacked bar shows relationships of individual items to the whole. This statement is very important. Why? Because the stacked bar shows you the percentage of each element of the stacked bar to the whole, something that you cannot see if you arrange the columns or bars in a clustered way. Let us see this example here. This is a table of Gulf countries, and there are some abbreviations here, and we are going to see for each country how much of these abbreviations is related to the whole. I don't want to tell you now what it means. I want you to think with me, what do you think these abbreviations means? What is so peculiar about Saudi Arabia, Kuwait, United Arab Emirates, Qatar, Bahrain, and Oman? The units is 1,000 cubic meters per day. Not to make you think too much, this is desalination technologies used in these Gulf countries, because in Gulf countries 2/3 of the desalination plants exist in the Gulf countries because they have shortage of water and they have plenty of affordable and cheap energy. This is why they desalinate a lot of water. Saudi Arabia comes first because of area and population, and all this are on the Red Sea and the Arabian Gulf. To know the meaning of these abbreviations, I made a special slides for desalination abbreviation, where MSF means multi-stage flash, the VC vapor compression, RO reverse osmosis, ED is electrodialysis, MED is multi-effect desalination. This is another data, and this is also progression with time. Again, when I see time, I have to look at the difference between the time, the intervals. Are they the same? Yes, they are the same. If they are the same, and because it's a trend with time, therefore, to show the trend, if the interval between the dates the same, I can use a line chart. A line chart here, I draw your attention that these numbers here, they appear as labels. It means that every number here is shown on the x-axis, and these numbers, because it is looked at as labels, appear between the tick marks, and the point itself, or the marker, appears in the middle between the two tick marks, and they are joined together to show you that the population of the world is changing with time. We are almost here, about 7.5 billion now, and we are supposed to reach 8.5 billion by the year, or the 9 billion by the year of 2050. A line chart is defined as it shows trends in data over a period of time at even intervals. Look at this, at even intervals. It emphasizes the rate of change over time because the slope of the line shows you the rate of change, and this is important. It considered x-axis as labels. This is why they appear on the x-axis. But this is a different type of data. We are going closer to engineering now. Why? Because we are showing the discharge in cubic feet per second and the concentration of total nitrogen expressed in milligram per liter. And we like to draw the relation between Q and the total nitrogen. And in this case, I need relation between X and Y, therefore I used a scatter chart. The scatter chart is different from the line chart. Why? Because these numbers, they don't appear on x-axis. They are not looked at as labels. They are looked at as values. Therefore, the x-axis is automatically scaled, and the computer internally puts these numbers, and you will find, because the interval between the numbers in the x-axis are not the same, I use this scatter graph. Importance of scatter graph to engineers, that I can find the best fitting curve. Not only that, I can ask the computer to write the best equation that represents this line and the R square, which is a measure of the goodness of fit, and when it comes closer to 1, it means it's a good fit. Therefore, what is scatter graph in definition? It shows two groups of numbers as one series of xy coordinates, and it shows the relationship among numbers in several data series. Of course, what we had previously is one data series, but we can have 2 or 3 data series. It shows uneven intervals of data, and it's commonly used for scientific data and especially used by engineers. The previous example is from water resources, again because I am a water management person. This is another graph that shows the results of people graduating from secondary. It shows a table showing of 3 people in a market selling certain products, A, B, and C. And for each product there is a price, and we are calculating how many items Mr. Jones is selling and the price of these items. Therefore, Mr. Jones is selling 200 items of product A and 50 items of product B and 5 items of product C. And because these are the prices, and we calculating here the numbers of items for each of the three investors, and these numbers here shows the price. These are the number of items that Mr. Jones is selling, and 550 is the price of these items. We want to show how these three investors are sharing the market. Therefore, we have, in this particular case, we are having parts of a whole. This is why we choose pie chart. Now we have two pie charts here, one to the left and one to the right. Again, the same puzzle. Which one represents the data better? The graph to the left shows these numbers here, like shows comparison based on the numbers of items, and to the right it shows the comparison based on the money or the amount of sold items in monetary units. This shows that Mr. Jones is better, but in reality Jones is not the best one, but the best one is Smith. Why? Because his revenues is maximum. Again, we can use this wrong pie chart to deceive people, as I mentioned before, but in order to make a fair comparison based on the revenues, we use the pie chart to the right that shows that Mr. Smith leads the market, followed by Mr. Baker, then Mr. Jones at the end. This is the definition of pie chart. It shows a relationship or proportions of parts to the whole, and it always contains one data series. This is one of the things that only is related to pie chart. Even if I have several data series, pie chart can only plot the first data series only. This is something related to pie charts when I want to compare two things. The number of PhD students registered in a certain engineering institution, postgraduate institution, in the areas of architecture, civil, chemistry, agriculture, electrical, mechanical, and textile. They are all engineering subjects. Some of them are registered as PhD students and some as MSc. These are parts representing a whole. Therefore, I wanted to compare two pie charts. The only way to compare two pie charts is to use a donut graph. You will see here, these are the different disciplines, and you can see very easily that the outer pie chart is the MSc one, and the inner chart is the PhD. Because to avoid confusion, I put the numbers, and this is an option inside to show you that 5, 3, 2, 1 are here. 5, 1, 2, 3, 5, 1, 2, 3 inside representing PhD, and the one outside representing the MSc. Therefore, this is description of donut chart. It displays data in rings, where each ring represents a data series. It compares two pie charts. The only way to compare two and even three pie charts, but we don't want to make compare too much pie charts because of the clutter issue, is the only way to compare pie charts is to use a donut chart. These are the students graduating from high school and in different subjects, and the final mark is 50, and we have three students, student A, student B, and student C, and we have 5 subjects: math, science, English, reading, and art. And we want to assign students to the proper college without considering the summation of the marks in the whole subjects. Why? Because we like to assign them according to talent, not according to total mark. One way of doing this, and this is my suggestion, is to use something called radar chart. This radar chart, as you can see, in this case I am using only 2 students, A and B, and using only 4 subjects: math, science, English, and reading. Therefore I am using this part of the graph here. It shows very quickly that the red student here can go to the Faculty of Arts because his marks in reading and English are better than his marks in math and science. And the opposite for the other student, student A is excelling in science and math. He can go to the Faculty of Engineering or goes to the Faculty of Science. If I like to put to support my decision, I add the 5th subject. But if I add the 5th subject, I will have 5 axes, all coming or originating at the center here. Therefore, this supports our idea that student A still goes to Faculty of Science, but student B will go to Faculty of Arts because his marks in English, reading, and art are high compared to the other student. This is the definition of radar chart. Each category has its own value axis radiating from the center point, lines connecting all values in the same series. This radar chart is used for many things, like people who like to play computer games. They will be very familiar with this type of chart. This is another peculiar chart. This is again in water quality area, in environmental engineering. It shows physical chemical parameters and the minimum value, the maximum value, and the average value of concentration. Or they can be other things, like say for example stress comparison in structural engineering. They can be velocity comparison in hydraulics, you name it. And I want to present this data to show the variation between minimum and maximum and the average value. This is too many readings summarized in a table by showing the minimum, the maximum, and the average. Therefore, I use a stock chart. The word stock chart because this chart is developed to present stock market by showing the minimum value, the maximum value, and the closing value. And this is how they show here. These parameters, this is minimum, this is maximum, and this is average. Beautiful chart, created for stock market but can be used for engineers. Engineers use a lot of things, and this is a definition of a stock chart. The stock chart is most often used to illustrate the fluctuation of stock prices, but there is a trick here. These charts may be used for scientific data to indicate fluctuation of daily temperature, for examples, or physical chemical parameters, physical chemistry parameters. The trick is you should arrange your data with high, low, and close entered as column headings in this order. To have the same pictorial image in the previous slide, you have to put high in the first column, low in the second column, and the close or average in the third column to get the stock diagram or the stock chart that is shown in the previous slide. This is also showing the post-industrial societies. This is Germany, showing the percentage of agriculture, industry, and services. Very important that these are percentages. How do I know? I added these numbers. 23 plus 34 plus 43 is 100. The same thing goes here and the same thing goes here. Therefore, they are percentages. If you add them, you come with the number 100 here is a series of dates. I have to check the dates as I said before. The intervals are not the same. Therefore, I used here an area chart to give you a pictorial image of the percentages that this country used to have agriculture as more than 40%, but because it's a post-industrial society, but the year 1998, the contribution of agriculture is small, and then the contribution of industry increased, and of course of services comes number one in 1989. However, this graph is not very good. Why? Because the numbers here, 1882, 1925, the distances are not the same. Therefore, the slope of the line or rate of change is not real here. Why? Because we are not following relative distances between the dates here. Therefore, even though it's an area chart, but there is a mistake here. Therefore, one of the things you can do is to think how to fix this using area chart. This is left to you. This is the only chart that I am presenting that has misrepresentation, because the numbers are under tick marks and the distances look the same, but they are not, because the relative differences between the dates. The area chart, it emphasizes the magnitude of change. It shows also the relationship to a whole by displaying the sum of plotted values. And this is a 3D surface. Maybe some of you don't know that Excel can produce this, but it does. And this particular graph is temperature in Greater Cairo, and it shows the months of the year starting from January and ending with December, and these are the hours of the day. And it shows here that the maximum temperature in Cairo is about 33 degrees, and it is almost at around like 2 o'clock in the afternoon. But of course, due to climate change, now we are in the months of February, and the temperature today was 30 degrees. Therefore, this graph is plotted before the effect of climate change in Cairo. And this 3D surface, it finds the optimum combination between two sets of data. Yeah, this sentence is written because you can, if you like to look for the maximum or the minimum value, you can plot in 3D graph, and then you can spot quickly where is the maximum or minimum. And also, the colors and patterns indicate areas at the same value as for contour maps, and you can control the number of steps and the colors, and you can convert this 3D graph into contour map, as you can see. And this is where I showed you that the maximum temperature happens in July about 2 o'clock in the afternoon. Maybe this maximum point was not shown in the 3D graph as accurate as here. This is almost my last presentation, or my last type of graph that shows how Egyptians are using mobile phones. Of course, the data is 2009, but it should be, we should add 10 years here. This is a number of people in millions using fixed phones, and this is the number using mobile phones. Things are changing now, but what I want to present is a type of graph called pictograph. It's a clustered column, but I am allowed, or Excel allows me, to change the color of the column and use a photograph or a picture. Therefore, this is called a pictograph, and it shows you by using the picture of a mobile phone. This is not a smartphone, or can be smartphone, and this is the fixed phone. And it's very clear from this graph that the rate of the users of fixed phones does not change much, but of course people are using and buying a lot of mobile phones. We come back to the musical break, but because this was a bit longer presentation and we talked a lot about, especially in the previous chart, about Egyptian conditions, I decided to give you a piece of music written by Verdi, which is the Aida Grand March. And of course we know that opera Aida is something familiar for Egyptian audience. I let you now enjoy the information and listen to a relatively long piece of music done by Verdi.